mute and just switch your video off and then come back at 1/4 past. Is that okay?
Okay.
Thank you.
Good morning, everyone. Welcome back to Middlesex's Summer Success Camp. We're going to start our maths session in about 2 or 3 minutes. Before we do, please, can you all register on Menti at 57 75 52 7? And Iram will be with us in a couple of minutes to start her maths session today. Thank you very much. Okay, guys, and I'd like to introduce Iram now, who will be running our maths session for you. So without further ado, over to you, Iram. Thank you very much.
Thank you. Okay, hi everyone. Hope you're all well. Welcome back. This is going to be the last session in terms of introduction to probability. So what we're going to be doing in today's lesson is basically revising what we've done over the last 3 lectures, as well as looking into a bit more detail what we covered at the end of the last session, which was the union and intersection. And we'll be doing some practice questions regarding some of the techniques that we've looked at. So let's have a look. So we'll start by revising some of the principles that we've covered in the last couple of lectures. So I'll begin with the 0 to 1 scale. If there's anything that you don't remember properly or your memory is a bit fuzzy on it, you can take down some extra. If you feel like you've already understood it, obviously this can just be a revision session for you. So the 0 to 1 scale. We measure probability on a scale from 0 to 1, as we said. If it's lying on this side of the scale, it's more unlikely. And if it's lying on this side of the scale, the probability is more likely. So 0 represents the impossible and 1 represents certainty. Remember, we said that the higher the probability of the event, the more likely it is that the event will occur. And anything that we say is likely has a probability of greater than 0.5. Anything unlikely has a probability of less than 0.5. And we can mark this on a diagram like so. Outcomes. So you should remember a key definition here. And if you don't remember, then you can write this down now quickly. So the definition of an outcome is the result of a situation or event. So if you remember, we looked at quite a lot of different situations and the outcomes of those situations. So if you play a game, the outcome is to win or lose. If you're rushing to school one morning, your arrival has the following outcomes. You could reach early, you could reach late, or you could reach on time. And obviously in probability, we calculate the likelihood of those outcomes happening. Now, what I've got here is the table of outcomes that we had from the first session, which gives us some situations and the list of outcomes. Because if you remember, what we did was we were listing outcomes for quite a while of many different situations. So we've got our 2 most popular examples here. If you roll a dice, well, the list of outcomes is 1, 2, 3, 4, 5, or 6. That's all the possible outcomes. Flipping a coin, heads or tails. Game of rock, paper, scissors, win, lose, or tie. So I'll give you a moment to answer some of these questions. It says, how many outcomes are there for the following experiments? List all the possible outcomes. So we've got 3 scenarios here. Choosing a number between 1 and 10, playing a game of chess, or choosing a day of the week at random. So I'm going to give you a minute or 2 just to think about those questions and have a go. Okay, so choosing a number between 1 and 10, well, that one's pretty straightforward. We would just list literally all the numbers between 1 and 10. So we'd go 1, 2, 3, 4, and then we just keep going all the way till 10. This is an example that we've seen before. So you just list all the numbers. Playing a game of chess. Well, I'm not sure if anyone here has played chess before, but you can either win, you can either lose. And if you're more familiar with the game, then you are aware that there's the possibility of drawing in chess, which is basically if you're both stuck and there's no more moves that you can make without exposing yourself. So win, lose, or draw are your 3 possible outcomes when you're playing a game of chess. Choosing a day of the week at random. So you would literally just list all the days. I'm going to do the letters: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So that's literally it. So well done if you got any of those. Okay, probabilities as fractions. Now, we've used this equation many times over the last few lectures, so I should hope that no one needs to remember this one. But even so, the probability of an event occurring, anytime we're going to present it as a fraction, we can put it into this equation. The number of ways an event can occur at the top and the total number of outcomes at the bottom. So remember, we looked at the example of a dice. So if you roll a dice, what is the probability that it lands on a 4? What about 1, 2, 3, 5, and 6? Well, we said that the probability of landing on any of these numbers on a dice is 1/6, because at the top we've got the number of ways the event can occur. So let's say we're rolling a 4. There's only one way that we can roll a 4, because only one side of the dice has the number 4 on it. So we put a 1 at the top. Then at the bottom, we say it's out of 6 possible outcomes, because there's a total of 6 possible faces on the dice. So the probability of landing on each one is 1/6, one option out of 6 total outcomes. The sum of probabilities. So think of all the possible outcomes of an event. All their probabilities must add up to 1. So this was a key idea that we looked at. Again, if you don't have this written down already, I'd say write down what's highlighted. The key idea is that for all outcomes of an event, the probabilities add up to 1. So we looked at the example of flipping a coin and landing on heads and tails. We know that the probability of landing on heads is a half, and the probability of landing on tails is a half, because it's a 50-50 scenario. And that when we add half and half together, we get 1, or adding 0.5 and 0.5 together. So when you take all the possible outcomes of an event and you add up each of those outcomes' individual probabilities, you must get 1. Listing outcomes. So we've done this quite a few times as well. We thought about the word outcome and how we defined it. We said that outcomes were results of situations, and that if we list all the possible outcomes in an experiment, we get something called the sample space. So again, key definition here, top sample space is the list of all outcomes in an experiment. So the sample space for flipping a coin is heads and tails. That's all the possible outcomes. There's nothing else that you can actually land on. So it's quite a small sample space for flipping a coin. Sample space for rolling a dice is a little bit bigger. It's the numbers between 1 and 6. And we also said that, okay, if we flip a coin and roll a dice, then we can list all the possible outcomes. So very quickly, if I flip a coin and roll a dice, could you list all the possible outcomes for me? I'll give you a moment to think about that. So if I flipped a coin and I rolled a dice, I can list my full list of outcomes by splitting my options into heads or tails. So this just makes it easier to list all the possible outcomes. So let's say every time we flip the coin, it lands on heads. So these are all my options. I can land on heads and roll a 1 on the dice. So I can write that as H1. I can land on heads and roll a 2. I can write that as H2. Land on heads and roll a 3. Land on heads and roll a 4. And you just keep going until 6. And then you do the same for tails. So T1, 2, all the way up to T6. Do the same thing. I've just not bothered to write it out in this case because it's just the same thing with the H's. So that's the full list of outcomes. H1 all the way up to H6 and T1 all the way up to T6. So this is all the possible ways, all the possible outcomes, but if you flip a coin and roll a dice. So well done if you got that. That is, again, one of the examples that we looked at in one of the earlier lectures. Okay, representing probabilities, also known as shortcuts. So we learned about some shortcuts to help us define probability. Let's say there was an event called A. We said that writing the phrase, the probability of event A, well, we can shorten that as just P of A. So the key bits here are in purple. Let's say the probability of this event A happening is 0.6. So we'd say that P of A is equal to 0.6. So if we translate this statement here, PA is equal to 0.6, it means the probability of event A occurring is 0.6. Okay. Then we looked at Venn diagrams. So we said that this was another way to represent some data or some information, kind of like a bar chart. But in this case, we use 2 circles. And the reason that we learned about Venn diagrams is that we worked out that it was quite useful to calculate probabilities. So very quickly, we said that if we have a Venn diagram, 2 circles with a box outside it, it often means that each circle represents a group or a set of items or numbers. And we sort things that belong into this group in one circle, things that belong into the other group in another circle, things that belong in both go in the intersection, and things that belong in neither go in the outer space, but still inside the box. Then we looked at union and intersection, and now we're going to get a chance to look at this in just a little bit more detail. So we said that we use the words union and intersection to describe the groups of numbers in a Venn diagram. So again, I briefly touched on this last week, but this time you'll get a chance to write down these definitions. So if you haven't already, I'd love for you to write down the definitions that are highlighted in green. So the union is the union of sets. Basically everything inside set A, inside set B, and inside both. So if you look at the diagram here, we say that the union between A and B is everything that's shaded yellow, basically, everything that's in both. And we write this union as A union B, with the union being a capital U. So if you can write down the definition of the union and then write down this notation here. So this represents the union. I'll give you a moment to write that down. if you like, you can sketch a very quick diagram and shade in what the union represents. But the definition should still tell you what that is as well. So next definition, the intersection. The intersection of two sets, let's say the sets are A and B, is everything inside the both section, i.e. where they intersect or overlap. The intersection is written as A intersect B, where the intersect sign is basically, it's kind of like this upside down U or a large N that's curved. So again, if we look here, we can see that the intersection is just the overlap bit, anything that's inside the both section. And we write that with this symbol here. So again, I'd like you to write the definition and the notation underneath. This, the shortcut way of presenting it, basically. And I do recommend that if you draw two circles and shade in the intersection just next to it, it can help describe what it is. Okay, hopefully you've got all that down by now. Okay, so finally, and this is probably one of the last things that we'll be learning in terms of like the content for probability. So union and intersection. Remember how we said that if we wanted to use the term, the probability that I pick something from group, or the probability of an event A occurring, we say that it's P of A, right? When it comes to Venn diagrams, we say the term P of A means the probability that I pick something from set A. So let's say for a second that I have, okay, let's say I have a Venn diagram, got my two circles that are overlapping, got group A here and group B. And then obviously I'm going to have my box around it as well. This is a very rough diagram. So if I have P of A, it means the probability that I pick something from set A, basically. So let's just draw that. So you're picking something from this set, basically. Similarly, if you have this notation here, which is P of A, oh, I see what's happened here. Okay, so what I'm going to do is I'm going to quickly correct this. And that means I put the intersection twice here. So now we've got the correct definition. Okay, so if I have P of A union B in the brackets, that means the probability of picking something inside the union. Basically, the probability of picking something which is in A or B or both. So it's the probability of picking something in A or B or both. So I'll give you a second to write this definition down. So in this case, this scenario here, the probability of picking something that's inside A, inside B, or inside both. Now, in this case, the P of A intersect B basically means the probability of picking something inside the intersection of A and B. Basically, the probability of picking something which lies inside A, both A and B. So basically, as we just previously described, it's the probability of picking something that's in the intersection only. So just that bit there. So I'll give you a moment to write this definition down, the probability of picking something inside the intersection. Okay, I'm going to give you a couple more seconds to just make sure everything's written down, especially the stuff in green. Okay. Let's move on. All right, so let's start some practice questions. So the diagram shows a fair spinner in the shape of a rectangular octagon. The spinner can land on A or B or C. Mark spins the spinner. Write down the probability that the spinner will land on A. So again, I'll give you a minute to have a go at this one and then we'll go through it. I've put a hint at the bottom, which is the equation or the key formula to writing down this probability. Okay, so we have to use our formula for the probability of an event occurring. So we know it's going to be in the form of a fraction. So the number of ways the event can occur. So we're working out the probability that the spinner will land on A. So how many ways can you land on A? So you've got 1, 2, 3 options to land on A. So we put 3 at the top. And then we put the total number of outcomes at the bottom. So the total number of outcomes is 1, 2, 3, 4, 5, 6, 7, 8. So your answer is 3/8. That's the probability of landing on an A. So well done if you got that. Okay, next one. A fish tank contains 8 guppies, 5 platies, and 7 mollies. So those are different species of fish. One of the fish is selected at random. Calculate the probability that the fish selected is a guppy. Again, I've put the formula required at the bottom, so I'll give you a moment to have a go. So we're again going to present probability as a fraction. We are calculating the probability that the fish selected is a guppy. So there are 8 possible guppies. We put 8 at the top. And at the bottom, we'll put the total number of outcomes. That's the total number of fish. So we've got 8 plus 5 plus 7. So if we add those together, we get a total of 20. So we put 20 at the bottom. So 8/20. You could also obviously put, you really wanted to simplify it, you could divide both by 4 and get 2/5. So either of those answers are perfectly fine. Well done if you got that. Jack has cans of soup which don't have labels. He knows that 3 cans are tomato, 4 cans are mushroom, and 7 cans are chicken flavored. If he picks a can at random, what is the probability that the can chosen is not tomato? Again, I've put the formula at the bottom, so I'm going to give you a moment to have a go yourself first. Okay, so we present our fraction. We want the number of ways that the event can occur. So the probability that the can is not tomato. So all we do is count the number of cans which are literally not tomato. So we've got 4 which are mushroom and 7 which are chicken flavored. So 4 plus 7 gives me 11. So I've got 11 cans which are not tomato flavored. We put this out of the total number of outcomes, which will be all the cans in total. So we've got 3 plus 4 plus 7. So we get 11 over 14. That's the probability of picking can, and it isn't tomato. Well done if you got that. All right, so this is another question with a spinner. Oh, let's go back. But this time we're going to be listing outcomes. So Isha spins a fair 5-sided spinner. She then throws a fair coin. List all the possible outcomes she could get. The first one has been done for you. So this is kind of similar to the example with the dice, except we're using a spinner. Not too different. I'll give you a few moments to list all the possible outcomes for this. Okay, so again, I like to list all the possible outcomes in terms of doing all the head outcomes first and all the tails outcomes next. And instead of heads and tails, I'm going to be putting H and T. So again, I've got 1 H, which is what they've just done, as in the example, 2H, 3H, 4H, and 5H because it only goes up to 5, the spinner. And for tails, say 1T, 2T, 3T, 4T, and 5T. It's pretty straightforward. So well done if you got that. Now remember that the order here isn't important. If you didn't do it, organize it in terms of heads and tails, that's completely fine. As long as all the outcomes are there, it's completely fine. There are 8 marbles in a bag. 4 marbles are blue, 2 marbles are red, and 2 marbles are green. Steve takes a marble at random from the bag. On the probability scale, mark with the letter B the probability that Steve will take a blue marble. Now, what you can do is you can just work out the probability and leave that as the fraction and think about where on the scale it would go. If you want, you could draw out a scale and mark it on, but you don't have to do that. As long as you just get the probability, and we can mark it on the scale on the screen. So if you work out the probability that Steve will take a blue marble, and then I'll mark it on the diagram. So we use the equation. So at the top, we want the probability that we're picking a blue marble. So there are 4 blue marbles in total. There's 4 blue marbles present in this bag. Then we put the total number of outcomes at the bottom. So we've got 4. Oh, there we go. So we've got 4 plus 2 plus 2. That gives me 8 marbles in total. So 4 out of 8 is the probability, which is, if we simplify, it's a half. So if we wanted to mark this on the diagram, we would just mark it here. Let's mark that. That's where B would go. Okay. Similarly, on the probability scale, mark with the letter G the probability that Steve will take a green marble. So I'd like you to work out the probability that Steve picks a green marble and then think about where it will go on the scale. So it's the probability that Steve will take a green marble. So there are 2 which are green, put 2 at the top, out of a total of 8 marbles. So it's 2 over 8, which simplifies to a quarter. So if I want to mark this on the scale, it's going to be, a quarter is obviously halfway between 0 and a half. So I'm just going to mark it here. That's where a quarter would go on the scale. And that's the probability of picking green. And finally, can you work out the probability that Steve picks a yellow marble? And think about where it will go on the scale. So in this case, so in this case, there are no yellow marbles available. So obviously we put a 0 and it's out of 8 possible outcomes. But regardless of what we have at the bottom, whenever you have 0 at the top, you get 0. So we mark this here. It's a probability of 0. The probability of picking a yellow marble. We can also say it's impossible. It's impossible to pick a yellow marble. So well done if you got that. Okay. Joshua rolls an ordinary dice. It has faces marked 1, 2, 3, 4, 5, and 6. write down the probability that he gets a 6, an odd number, a number less than 3, or an 8. Give you a minute to have a go. So the probability that he gets a 6, well, we know that the probability of landing on any one face on the dice is always 1/6, because there's only one option that has a 6 on it. An odd number, well, what are the odd numbers here? We have 1, 3, and 5. So that's 3 options. So we have 3 options out of 6 options. So it's 3/6. You can also simplify it to a half. What is the probability that he gets a number less than 3? Well, there's only 2 options which are less than 3, 1 and 2. So we put 2/6. You can also simplify this to a third if you like. And what is the probability that he gets an 8? Well, there's no 8 on a dice. It only goes up to 6, so it's impossible. The probability is 0. You could also put 0/6, but it means the same as 0, of course. Okay, so I've got some statements here, and obviously it says draw an arrow. But all really I'd like you to do is just think about which word is the best for each statement. So there's 4 statements here. You just have to think about which word best describes the likelihood of each of these events. One's been done for you. So the probability of it raining every day for a week in July in London is unlikely, because obviously it's an event that's happening in the summer and it's just unlikely that it will rain every single day. So for the other 3 statements, please have a think about which words are best to describe the likelihood of those events happening. I'll give you a moment to think about it. Okay, so the probability that a head is obtained when a fair coin is thrown once. Well, we know that with heads and tails, there's always a 50-50 chance. So we say it's, oh, let's just go back for a second. There we go. So we say that there's an even chance when it comes to landing on a head. A number less than 7 will be scored. When an ordinary 6-sided dice is rolled once. Well, when a dice is rolled, all the options are less than 7. There's no way you're going to land on something that's not less than 7. So we say that this is certain. And finally, a red disc is obtained when a disc is taken at random from a bag containing 9 red discs and 2 blue discs. So for this last one here, we know that at the top we put it's 9 red discs being chosen out of a total of 11 discs. So if it's 9 out of 11, that's quite likely, I would say. So I'm gonna draw an arrow from this to likely, because 9 out of 11 is, well, it's the majority, isn't it? The majority of the discs in the bag are red. So we say it's pretty likely. Okay. The probabilities of a spinner landing on each of its 3 colors are shown in the table below. Complete the table. So the key here is we're using the idea that all probabilities add up to 1. So bearing that in mind, I'll give you a minute to have a go at this question. You're working out the missing probability here. What's the probability that this spinner lands on red? So for this question, we're using the idea that all probabilities, or the probabilities of each outcome in an experiment, they all add up to 1. The total is going to be 1. So what we're going to do is we're going to add 1/3 and 1/6 together. So first let's get the sum of those. So if you remember anything from adding fractions, make the denominator the same. 3 times 2 gives me 6. So I put 2 at the top. 6 times 1 is just 6. So we make the top a 1 there. So we get 3/6, which is also a half. So when we add those two together, we get a half. Now we just have to subtract that from 1. And we know that 1 take away a half is just a half. So we know that the missing probability will just be a half. So well done if you got that. The table below shows the probabilities of picking different colored counters from a bag. Fill in the missing probability. So it's basically say this is the probability if you get a red, this is the probability if you get blue, this is if you get purple. Work out the probability of picking a green counter. And then as a second part of the question, it said, what is the probability of picking a red or green? So I'll give you a moment to think about it before we have a go. All right, so again, we're using the same concept. We're using the idea that probabilities add up to 1. So if you add up all these, 1/3 plus 1/6 plus 1/4, 1/3 plus 1/6 plus 1/4. Well, we saw in the previous example that 1/3 plus 1/6 is a half. So if you add a quarter to that, you get 3/4. And then we want, for the missing one, we subtract that from 1. So 1, take away 3/4 is just a quarter. What's the probability of picking a, so that was part A. So well done if you got quarter. Let's do part B. What is the probability of picking a red or green? So in this case, what we would do is we would take the probability of red and the probability of green, and we just add them together because we haven't been given the number of counters. We've just been given those probabilities. So what we can just do is simply add them together. So 1/3 plus 1/4. You add those together to make the denominator the same. So you get 7/12 if you add those probabilities together. And that's the probability of picking a red or green. So well done if you got any of those, especially if you managed to get the second part of the question, because it's not as straightforward. Okay, so we've got a Venn diagram here, and it's got a couple of numbers that have been put into it. So write down the numbers that are in the set A union B and A intersection B. So I will give you a minute to do that. So start with the first one. So let's say we're looking at the union. Well, we said the union was everything that's inside set A, everything inside set B, and everything inside both. So you would just write down all the numbers that I've just highlighted. So quickly, we have 15, 12, 18, 10, 16, 14. And the intersection is everything that's in the overlap. So it would just be 12 and 18. So let's put 12 and 18. So well done if you managed to get that. Okay, we're going to move on to the final question for today's session. So I've got a set of numbers here between 1 and 20. And I've got an empty Venn diagram where A represents prime numbers and B represents multiples of 5. So what I'd like you to do is put the numbers between 1 and 20 into this Venn diagram. Okay, so because we are running just a little short on time, I will quickly write up the answers for this. So just as far as you've gotten, you can just see which numbers you put in correctly. So in A, we'll put all the prime numbers. So 2, 3, put 5 in the middle because it's both prime and a multiple of 5. So next prime number is 7, got 11, 13, 17, and 19. And then in the other one, we'll put multiples of 5. So we've got 10, 15, 20. And anything that goes outside is neither prime nor a multiple of 5. So we've got 1, 4, 6, 8, 9, 12, 14, 16, 18. Okay, I think that's everything that we've covered so far. So that way we've organized all the numbers into our Venn diagram. All right, we will finish there for today. Oh, I forgot to clear the board. There we go. Thank you so much for listening, and thanks for being patient because we are reaching the end of the session. I hope you guys have got something useful or something interesting out of these sessions. And thank you so much for listening.
Hi, Aram. Thank you very much for that great math session just then. If everyone could please log back into Menti now using the code 5775527 and just write down what they've sort of learned from that session, that would be great. And then we're going to have a short lunch break. Our next session will start at 1:15, where Ross from Chocolate Films will be joining us and teaching us all about some video editing. So have a great lunch break, everyone, and I'll see you shortly. Bye.